This is a Lowell Observatory podcast.
5, 4, 3, 2, 1, 0.
Welcome to Star Stuff, a space oddity.
Hi, and welcome to Star Stuff. My name is Cody Half-Moon, your host, and today I am here with Jeff Gehring, who is one of my best friends. And I actually I just realized I don't know your title. Machinist engineer extraordinaire officer.
Sure, that's maybe the way things started. I'm currently the tech facilities manager here at Lowell Observatory.
Tech facilities, okay,
Yeah.
I'll remember
I manage a small team that our main duties are taking care of the large moving structures, the domes, the telescopes for all of our on-site and off-site telescopes.
And Big Red.
And Big Red.
Which we'll talk about, of course, because I love my cars. So I want to start with how you got into this. That's really specific, is machining parts and restoring telescopes, just in general. But I know that's not where you started. And I have spoilers because I actually know.
Yeah, you know a little bit.
Pretend I don't know. How did you?
I kind of got here in Flagstaff kind of haphazardly.
You have to tell about the darts.
Oh, yeah, okay. So I was looking for a new job and just kind of needed a new lease on life. I had been machining for about 15 years at the time, working in aerospace, becoming kind of a hard metal specialist. We did a lot of AOG work, stuff like that, right? Airplane on ground for the layman.
Airplane on ground?
Yeah. So
that's the opposite of what airplanes should.
Exactly. And, Boeing estimates that every minute that an airplane sits on the ground is about $1 million or something like that.
What? What do you mean?
Lost revenue. Yeah.
So, you're machining things that stay?
So if they don't have any spares in stock, they will contact us, and the Air Force does this too, where they'll contact us and we'll produce a part for them as absolutely fast as we can to get the plane back in the sky.
Oh, okay.
Right?
So while it's on the ground, is it like the pit team in NASCAR?
Sure. Yeah. Yeah.
Okay.
Kind of like a super, super expedite, if you will.
Okay.
Right. I kind of was just bored with aerospace and some of the military R&D work
so
that I'd done, and was looking to get out of Washington because I was tired of the rain. And I was over at a buddy's house and decided I think I want to do something different. And I wrote 4 city names on a piece of paper, hung it up on a dartboard, threw my dart and hit Flagstaff, and I moved here.
Without a job. You were just like, I'm
Didn't have a
going here. I'm going
job,
to take off a while.
Had money in the bank, figured I could live here a year before I needed to do something else. And moved here, and I was here for about a month and a half, and ran into a local connection who said that Lowell Observatory was looking for a machinist, and I said, well, what's a Lowell Observatory? I knew what observatories were, but the way he said it, I just didn't know, and I didn't know anything of the history of Lowell at the time. And we've got quite the colored history. I'm sure everybody else talked about that on the podcast.
Oh, we have a few episodes about,
Yeah.
the craziest stories, and then just your general. So people, if they're watching, they should know.
Yeah. So I ended up landing a job here as a machinist with Lowell.
What does that mean?
Machinist? I operate machine equipment to produce things out of raw stock metal, right? So I would work with the instrument team. At that time, I was part of the instrument team, and they would come up with a crazy design for a metal object to hold an optic, or even a full design for instrumentation, the housing, the block that mounts to the telescope.
These are large telescopes, or
This was mostly for the LDT when I first got here that we were working on stuff for.
Right. Because that would be 10 years ago-ish.
Yeah, I've been here a decade now, so I know. Yeah, last Thursday, a decade.
Congratulations! Yeah, wow. Old, huh?
I know. I'm starting to feel like an old timer around here, all the white in my beard.
Oh,
anyway.
man.
So, they come up with a schematic drawing, right? And give you a model or whatever. And it's your job to produce that from a block of metal and whittle it down to make it the exact shape within, the tolerance of the human hair, or a quarter of. Oh, yeah.
I was about to say, is 3D printing going to take place of that? But maybe it sounds like not for a while.
I'm a huge believer in 3D printing, especially what metal 3D printing can produce. There is processes in 3D printing and metal 3D printing where you can produce things that are incapable of being machined. Internal square corners, some of the ducting, like I know.
Square corner. Oh.
Yeah, you cannot machine a square corner except for with a points EDM, electro discharge.
Heavy metal, EDM. There you
go. I can't remember what EDM stands for.
I know these words.
Right. So that's the only way to get like a theoretically square internal corner is with a points EDM machine. Anyway, so yeah, they, and you, gosh, I wish I had brought a couple of examples or something. So I get, big old block of steel and I whittle it down until it's the exact shape. And most of these things are whistle. Yeah,
while you
whistle
whittling?
while I work.
Okay.
Yeah.
Well, I just picture like whittling.
You're such a dork. Yeah, I do with a little pocket knife on these steel blocks and make everything. No, we got big old machinery. In your
rocking chair in the machine shop.
Lathes, mills, CNC mills, saws. Sometimes you're down to files. Sometimes we did some photo etching processes to like cut copper sheeting into transferring of thermal properties between thermal heads to cool off CCDs and stuff.
Barely know what you're saying. Wait, so thermal, so like it captures.
Well, a major thing with like cameras and electronics is the heat transference, right? CCDs don't work at high temperatures. That's why they're always chilled with like Stirling coolers and liquid helium and the such, right? Oh, I guess we got to do a field trip and teach you some things. So, you got to keep the CCD really, really cold. A camera.
Okay.
For the layman, yeah.
Okay.
So like the LMI camera, that is a
large
CCD.
Megalithic imager.
Yes. That is a CCD that I believe is roughly that big, right? And each of those is like a little pixel, right? And that has to be at a really, really stable temperature or else you get faulty information in your imagery.
I see. And this is what the tool that's attached to the Lowell Discovery Telescope.
Yes.
For imaging the night sky.
Yeah.
Okay.
So transference of heat. You want to suck away heat from those objects, and you have to do that in a way that doesn't transfer vibration, because.
Yeah, that makes sense.
So we make these really interesting cold heads, right, that will transfer heat without transferring vibration.
So you just learned how to do this on the job?
Well, yeah, I learned a lot about, instrumentation and telescopes here on the job. I'd never been to an observatory. We don't have a lot of them in Washington State because
I would imagine.
It's always cloudy. And, we get 300 sunny days a year here in Flagstaff, so it's pretty awesome.
That's cool. So it just kind of happened.
But
now you're
I landed
the manager.
Here at the observatory, and the first big project that I got stuck on was we did a restoration of the historic Clark telescope.
Yes, I want to talk about this in depth a little bit because so like I said, Jeff is one of my closest friends. And I think it was like a year into me working here, because I knew you before I started working here.
Yeah.
I realized that I had never been to your office and I had no idea what you did here. So you're like, are you kidding?
I was just
are you
another
serious?
Pretty face
just another pretty face.
Yeah.
So I was like, and then I learned what you did, and I still didn't even understand it because it was the tour that I was giving. Was it NASA students or maybe Arizona Science Center? I can't remember.
Oh, out at the MPOI?
No, here on campus. And I want to say broke into the Clark because it sounds cool, but I have a key. But got into the Clark, and you were in there or nearby, and you're like, oh, do you want me to give you a tour? Or, do you want some context? I can help you out because I'm struggling. I'm like, it's a Victorian telescope, and it helped discover. So I didn't know anything about how it worked. That you machined the bolts during this restoration to match, or the screws?
Yeah. So an interesting process happened with that telescope. Like I said, I kind of hired in, and that was the first thing that they stuck me on was we're going to do this restoration of this, 113, so 120-year-old telescope roughly, right? And I've worked on old cars and stuff my whole life. I'm a big car freak. Too.
And last Saturday.
And last Saturday, yeah.
Thank you.
First car I ever drove was a 1936 Plymouth that my grandfather owned, right? And like
Zero shock.
the first time they got me, sitting on his lap behind the wheel kind of thing. My mom might know that. Don't listen to this, Mom.
Hi, Jeff's mom.
So yeah, I mentioned like all the old stuff, right? And old metallurgy and being a machinist, I've worked in all kinds of metals. Well, we start tearing apart this telescope and some of the hardware was wrong, right? It was mismatched. It didn't match the right era. It wasn't an original bolt, right? A bolt would break and they'd replace it with whatever you had around because
it's been around for over 100 years. I mean, yeah.
And the telescope, unlike like restoring an old car, it's a working tool, right? It's worked every day of its life. So it wasn't important that it looked the part, right? That the bolts all matched.
That it worked.
What mattered was that it worked, right?
Right. And give us some context, like just so people can picture it. Like how big is this thing? How old is it?
The telescope itself is 36 feet long.
That sounds right.
Yeah, you could insert an image here.
Oh, yeah. Right here, Nate. Just a little,
and
one of your beautiful photos, please.
It's, I think, about 4 feet around at its biggest point, the central pivot point.
4 feet?
Yeah, it's maybe three. Yeah. Heavy.
Jeez.
And it weighs, I want to say, right around 3,600 pounds for the movable portion. And then the base itself weighs around 3,600 pounds. Yeah, it's a big, heavy thing.
It's huge and gorgeous. It's very steampunk.
So when we start tearing it apart, we made the decision that we are going to powder coat this telescope. And it was covered in lead paint.
Oh,
right?
Okay.
And lead melts at a low enough temperature that we had to get every single little bit of lead paint off the telescope. So
you knew this telescope intimately at this point.
Oh, yeah. I know every bolt on that telescope intimately. So yeah, we strip it down. We used, I get confused on this. It's either lead sulfate or phosphate. One of them is dangerous, absorbed through skin or breathed, and the other is not. And there's a lead neutralizing stripper that flips it one way or another. I can't remember what it is. So we use that and then all the proper garb and ground every single little bit of paint off of it, right? Well, in disassembling all the bolts.
How long did this take?
It took about a year to do the telescope, and then we had to wait for about another 5 months because of weather to reassemble it and put it back in place.
Oh my God.
So, yeah. So
that sounds like a fun puzzle, though.
Oh, yeah. It was great.
Jigsaw.
Lots and lots of pictures. And I had plenty of help. I had my mentor here was Ralph Nye, and he was an engineer. He'd been here. He retired after 43 years. With the observatory. And we had Peter Rosenthal was working in the office with me, and he was a camera repairman from Flagstaff here and was just really good with chemicals and finishes. That was his expertise, whereas mine was kind of the metal, right, and mechanical. Tearing things apart, putting back together is...
Sounds about right.
I've been doing it to my father's chagrin since I was a child. Tearing apart things I shouldn't have.
How many toasters did you break as a kid?
Probably lots, yeah. So anyway, yeah, when we're tearing apart these bolts, like some of them were mismatched and didn't fit the era. And it was really important to me that we restored the telescope.
Jeff is a perfectionist, by the way.
It comes with the trait of being a machinist.
You're very perfectionist,
right?
Which is great.
Most people work within quarters of inches. I work within quarters of thickness of hair, right?
Oh
Your typical human hair is about 3 thousandths thick, and I'm used to working down in the tenths of thousands. So yeah, perfectionist comes with the territory.
I don't see. I just learned that. I didn't know that you did that.
Yeah.
Wow.
So Clark telescope built in 1896, right?
Stripped it down,
took it all apart, and the standardization of bolts for thread pitch and sizes didn't actually come around until I believe it was 1932 was the SAE standard.
There were no standards before that.
Yeah, there wasn't.
Just whatever
I think
you
that
did.
was the year, yeah.
Okay.
I forget because I did a lot of research at the time to make sure I was restoring things the best that I could. But like some of the bolts on this telescope were not your standard pitch where I could just buy them off the shelf, right? Like half 13, that's half inch diameter, 13 thread per inch, right?
Oh my God. Jeff and I he was helping me with my car, and we were just at Napa.
Yeah.
No, we went to Homeco. It's like a local lumber and
hardware store.
And he's like looking through these bolts. And he's like, oh, this is a 1/25 3/4 inch. And he's not even reading the thing. He's just like, oh, I think that looking at that screw, that's a 1 whatever. And I'm just like drinking my coffee that they give like at the front desk. Like,
yeah.
Okay. It was really impressive.
Yeah.
Because fraction's not my thing.
But that's the world I live in, right? It's mechanics and bolts and everything like that. So some of these bolts are not standard sizes, right? I can't even go to a shop and buy a tap to chase the hole to make sure all the paint is out of it and stuff, right? So some of these I actually had to take a piece of raw steel, machine the threads on it, cut the grooves to make a tap out of it, harden it, you get it nice and hot, and then you quench it in oil so it hardens it. So I could chase the threads in the material to make sure the threads were in good shape and,
Jeez. I'm assuming clean. There are a lot of bolts on this thing.
Oh, yeah. I can't even imagine how many bolts there are. There
are a bunch.
A ton. Yeah.
This is, if you picture like steampunk design. This
was built at basically in what you imagine old ships being built, right? Cast iron and then rolled sheet metal with
pirate
rivets,
and cowboy days,
right? And so it looks like an old ship in design and
you're
and
right. It kind of does.
Yep.
Is that what we call it, a her?
Lots of brass on it, stuff like that, right?
I have been asked why so many people refer to Clark as like she, or like she's doing this, and Clark
really?
Is like a male name.
Yeah.
And I was like, look at her.
Huh.
She beautiful. She thick. She's perfect.
See, whereas mechanical things to me have no gender. I'm one of those people
yeah. You don't.
No,
yeah.
My cars don't have names.
They don't. I know. I was upset about this when we first talked about your cars not having names. Yeah. It's like, do you even like them?
Oh, I love them. I'm obsessed with them. Uh-huh. So not only did I have to make taps to chase holes for existing hardware to make sure everything was clean, some of the bolts I actually reproduced from scratch. So I'd take a raw piece of material, right? Cut the threads on it so it'd match the same size. Mm-hmm. Cut the head down so it'd be emulating the old style of things.
Literally what they probably did to make these bolts.
Yeah, similar processes, yeah.
Jeez.
And yeah, but some of them, like I said, because the thread pitches just were something you can't buy off the shelf now. And that brought up a really interesting thing about like forensics, right? This is what I called mechanical forensics.
Ooh.
Where I would tear into a process on the telescope that was a modification, because it's a working tool. It's been modified every couple of decades. Somebody wants to do a new science project with it. Technology
like
changes,
layers of years of changes.
So it originally was just an eyepiece. Then we added the spectrograph for Slifer, right? And then we put in the blue filter for the Apollo project, right?
Wasn't the thing that Slifer put on there, isn't that what sort of like discovered the expansion of the universe?
Well, yeah, my understanding, and I'm not an astronomer, right? In fact, I don't know a whole lot about the science. I know a lot about the mechanics, right? Was that he discovered what was defined as the redshift.
Mm-hmm. That then Hubble heard at a AAS presentation.
And used that working theory to come up with the expanding universe theory.
I know the tool was put on the Clark.
Yeah.
That found the evidence of the Big Bang. And then also the rings of Uranus. I believe that was a tool that was added to the Clark.
I don't know on that one.
Yeah, I think I remember reading that too.
But I know that like a lot of the lunar mapping of the was done on the Clark.
For Apollo.
So like all these modifications, right? Mm-hmm. Well, I'd look through for what was the process for this modification to see what year kind of was this modified, and then go back as deep as I could to make sure that things were fitting that standard.
I bet you were just so happy.
One of the examples I like to give is there was this modification to the end of it for the spectrograph.
Okay.
And it had these windows and they were filled with like chunks of aluminum, right? Just aluminum sheet metal.
And this was to take photos through the Clark.
This was for the spectrograph.
Yeah.
Yeah, no photos, just spectra.
Spectra,
right?
okay.
Yeah. Excuse me. So the aluminum plates didn't look right.
Didn't
Okay,
look
they were
right.
way too modern for the telescope with all this brass and no other aluminum on it. So I replaced them with like brass, thinking that would fit more to the era of it.
Okay.
Right? Well, the first thing I did was engine turned the brass, which is the process that you see on really old airplanes and old cars where the dashboards have like all this spun brass on it.
Yeah,
right?
I know what you're talking about.
I did that and I started thinking about it. I was like, when did engine turning become a process? So I hit the patents, right? And engine turning wasn't patented till like 1911 or 1913. I'm like, well, that's like a decade too new for the telescope, right?
Uh-huh.
So I went back and I polished out all my engine turning because it was too
Oh
modern
my
for the telescope.
gosh.
We look at modifications and if they were arc welded together, when did arc welding become patented? Okay, that's probably when this was built.
Oh my
Well, this
God.
was clearly turned on a lathe, right? When would this process have come up? So that's how I discovered a lot of like
I bet you loved
mechanical forensics.
that. Nerding
yeah.
out, researching. Yeah.
So in the time of doing all this, right, they discovered that not only was I a machinist, that I had some pretty strong mechanical skills and mechanical understanding. I'm not an engineer. I'm not
Yes,
an
you-
engineer.
Okay.
Okay.
Fight
Engineers
for
are
a
something.
different
It's-
day.
Yes, fight for another day. But I have pretty solid understanding of mechanical things. So my time, my time ended up being pulled away from the machine shop to help with mechanical analysis and repair of so many of the telescopes and the buildings. You know, almost all of our telescope buildings here have big mechanical systems to open them up and rotate the entire building. And you know, there's wheels that have to rotate and spindles and bearings and drive systems and all this stuff, right? And it turned out that I was getting so needed in those areas for my mechanical analysis to help out Ralph with that I didn't have time to machine anymore. I really had no time to actually run a machine to produce parts. So the decision was made that, you know, I would start training up with Ralph a little bit more, knowing that he was reaching an era where he had talked about retiring after 43 years in the industry.
Oh,
I mean,
man.
well deserved. And so I started to follow along and do that a little more in depth. And then when Ralph decided to retire, we took the opportunity to kind of divide things up a little bit into the maintenance side of things. I hired a new machinist to replace me, who I'll just say it on camera here. I think he's a better machinist than I am. So put that feather in your hat, right? Jared. And so now I lead just a small team, and I've got construction worker, carpenters, woodworkers, people who understand electronics in a more in depth than I do. And it's our job to run around and take care of all these domes and telescopes.
And cars. Before we end, I want you to talk about Big Red. So Big Red, is it 1911?
It's a 1911
Yes.
Stevens Duryea. And it was Percival
This is an
Lowell's.
old car.
It was Percival Lowell's personal car. He ordered it, had a custom coach worked for the body to be 9 inches wider than the standard one, so that his wife could sleep in the back seat because she didn't like sleeping in a tent. And
What?
That's what it was. That's why it's wider in the back. Yeah.
What do you mean?
His wife hated sleeping on the ground in a tent.
Why would she be doing this?
Because they would drive around to do occultations or observings out in the desert.
She went with him, my goth princess. Oh, God, I love her.
So, and then they throw a telescope in, they drive out into the middle of the desert to do different observings.
Excuse me, that's so romantic. Okay.
And now I'm part of a volunteer team here at the company that takes care of her. She's still running. There, I said she.
Yeah? She's beautiful. It's
And-
red, very... I've never seen another car like her.
Yeah.
It's amazing.
It's fascinating.
On display,
So it's,
too, at the PCC if you're up here for viewing. But sometimes it's not because you're fixing her up to
Or driving her.
Or driving her. I know. I haven't been able to drive her yet. To lead parades downtown for Flagstaff, go to car shows, stuff like that.
Sure. Yeah.
She's famous.
Yep. But as far as we understand, we believe that she's the last running of her model in the world. That's what we've been told. We're not car historians here, but that's what we've heard. And we team up an effort to keep her running and driving. And I've been recently teaching the rest of the team on how to drive the car, so I'm not the only one in case I get hit by a big truck or something. You know,
as it happens all the time.
Yeah.
So I'm curious also, because I have a few things I definitely want you to talk about. One of them are of the stories that you can share. I'm curious, like, what is something that happened that was like a, whoa, you didn't expect that, or it set you back by a lot, or that was kind of a surprise, or that stand out in memory from fixing pretty much every mechanical thing on this historic campus and off campus, the J1M. What I just called
we have the Anderson Mesa site, and
the LDT and Happy Jack.
LDT and Happy Jack as well.
So you've been around the campus and off campus and off sites and working with the government
that I
and
don't have keys to or don't get involved in at this point. Yeah. There's been some interesting things, you know, like finding historic artifacts that like are tucked away underneath a telescope, you know.
What? Tell me about this.
Super old oil cans that we found underneath the Clark.
Right, there's all that rocks. Space too.
Well, no, this was like sealed in behind panels underneath the steps. So it's like it's all raw rock underneath there. And we had to get access to look for some wiring issues and found like a super old oil can.
That's
and
awesome.
stuff like
I love that you kept the pencil writing inside the Clark too.
Oh, yeah.
The mathematics and wasn't there directions to a bar downtown?
Somebody's got a drawn. I heard that there's a.
I've heard this
bar,
myth, yeah.
But somebody's got like a bell curve drawn out there for calculations. There's a whole bunch of stuff like that, and we were really careful to restore all that stuff.
Yeah.
Right. We cleaned it very delicately, and then we'd actually clear over the top of it, so it's retained for preservation.
Awesome. These scientists will like be up observing at night in the Clark back in the day, and would just turn and do simple math equations on the inside of the Clark, interior of the Clark, in their pencil.
There wasn't a paper notepad around, so they just write it right on the wall.
Scientists.
Yeah. Let's see. I think one of the things I can talk about that was funny was in the Clark Dome. Opening up a cabinet door as we're just going through and repairing some of the wood and finding a man sink in one of the holes. That's what I've heard it referred to as.
What?
Basically a urinal. Yeah. You didn't know that?
They just pee in there?
There's a urinal in the wall in the Clark
What's
Dome.
it drained to?
The rocks.
Wait, where in the Clark?
Well, I don't want to tell everybody.
Oh, no.
They'll be looking for it. So that was one of the funnier things. Or finding like...
Did you ever hear this? It's so good.
Really old business cards.
A man
some
sink
really neat old tools, right? That just got left behind by my predecessor mechanics, like...
Business cards.
Old business cards and stuff. Yeah, that's kind of been like the finding, and then, interesting old stuff. But then understanding some of these mechanical systems is far more interesting to me. The way that we do things now is just so heavy with electronics to define things, and everything has to be mechanical and electrical, like to these crazy degrees of precision. And to tear apart these old things, like the Clark was originally gravity drive. There wasn't electricity to the telescope, right?
Right.
So its old drive system was lead weights and a cable to a gravity drive system that spins.
Yeah.
And then it rubs to slow down, right? Rubs little felt pads against a disc. So finding out how those systems work and how elegantly they worked in comparison to having to have computer boards and chips and electronics and readouts and stepper motors, like it just worked, and it feels like sometimes, as much as I love technology, like we're going backwards by using technology as a crutch for everything, right?
Well, I mean, it's just like the classic parallel to that would be Jurassic Park.
Sure, yeah.
CGI versus
Practical effects.
the practical effects.
Oh, I'm a huge fan of like...
The practical effects will win every time.
I'm a huge fan of like the Jim Henson,
Yes.
art of
Puppetry
building
and-
puppets and practical effects. Yeah, I love that stuff.
It's ageless,
Yeah.
I think.
So
That's amazing.
a lot of it is digging through and rediscovering how did they build this, and that comes up with the Clark too, but that's another episode.
Yeah, the Sykes.
Well, I think in 1903 exposure time for a picture, 1896 exposure time for a picture was like 3 minutes or something like that.
3 minutes?
Yeah. So as a worker, you tell me I'm going to hold a heavy wrench for 3 minutes for you to take a picture of me assembling something? Ain't going to happen. So we have no pictures of how that telescope was built. And with how heavy everything is, it's our version of the pyramids is how I joke about it.
Yeah.
We had to look at it knowing that it's been there.
Do
our
archaeological
entire
work.
lives,
Yeah.
But how did it go together?
That's
We don't
awesome.
know. How does it come apart? We don't know.
Well, now you know.
Right? Well, now we know.
So I'm curious, one last question, because I think Nate's given us the time. If there is someone who is listening who has an interest in engineering and mechanics and that kind of thing and has a love for science, what's the best way to fall into this sort of position these days? Like someone that you would hire, for example, on your team.
I will say that myself, I don't have any kind of education outside of high school, right? I didn't. That's why I say I'm not an engineer, because I didn't.
But that's
go to
why I
school,
say that you are.
right?
Capitalist society.
I look for, when hiring people, trainability and natural aptitude, right? You can learn a lot of mechanical things, but somebody who looks at stuff and can just figure it out or intuitively understand how a system works, right, is great. So start young. Don't be afraid to pull apart mom's toaster.
Yeah.
It's incredible. Yeah. I will say, like, a little plug, if I can. When I was a kid, I got a book, which I believe is still in production now. I think it's on version 7. It was called The Way Things Work. And
Not a
I know
sponsor.
it's available on Amazon, not a sponsor. And I got that book when I was a kid, and I've read through it so many times.
Really?
And it was just, how do all the simple machines work? How do electronics work? How does a toaster work, right?
Yeah.
And it inspired me to just be my love of mechanical things ever since.
Yeah.
So I would say, don't be afraid of things, tear it apart, see how it goes. Get yourself some basic tools and go at it. Yeah.
Awesome. Well, thank you so much, Jeff. We adore you, and thanks for coming on the podcast. And if we get any questions, you can send them through to our Star Stuff Discord, and I will make Jeff answer them for us. So yeah, thank you.
Thank you.
Bye.
This podcast was made possible by our members and donors. If you enjoyed this episode and want to support our nonprofit in making more digital education like this available, go to lowell.edu/donate. Thanks for listening.